And I'm back. I skipped an example, the one that's got the blue thing. I'd rather go work with this example here, and then I'm going to show you guys how to do it. So, what we're doing, we are ultimately making OH gas from oxygen gas and hydrogen gas. And you may notice, wait a minute, oxygen gas and hydrogen gas like that? Right. Well, wait, Canu, that's unstable. You're right, they're not. And that's part of the process. It's a transition. These are not going to be stable for very long, and they're going to connect like this. Okay, but the idea is we're looking at how many kilojoules there are in 1 mole, and you'll see. So this is the information we're given. We've got these different steps that are happening, and we're going to calculate our delta H0 for this reaction. So let's switch out. So I have my information here. Notice I did it in black, red, and blue, so you can see where it's coming. Now the thing about Hess's law that we can switch the order of the chemical reactions, okay, to make it fit for what we need to do here. If we switch the order, then we need to change the sign from, in this case, a positive to a negative. Okay, we get to do that. Now sometimes we may need to multiply by something, so then we would have to multiply whatever that delta H value is by whatever number that we need. Okay? So this is what we did. I went ahead and I did a little bit of switching the order. So I've got here O2 plus H2 gets 2OH plus 77.9. All right. Now notice I switched the order from O2 to 2O. Notice how that got broken, that connected, and that's negative 495 kilojoules. Whereas up here it was plus 495 kilojoules. Well, wait a minute, what's happening? This is an exothermic reaction that's going. Okay? The heat's being given up. The heat is on! The heat is on! Yeah. Alright. Now, when we look at the next one, we also had to switch the order, and that's also negative 435.9. Notice up here, with the original value, it was plus 435.9. All we did was switch the direction. The heat is on! The heat is on! Okay. Now, what do? Well, we're going to take all these and we're going to put it into one big giant equation like this. And again, I kept the color so you guys can see where it's coming from. So I got the O2 plus H2 plus 2 oxygens. Now you know why I put slashes through my zeros. Yo. You got the plus 2H, you end up getting 2OH minus plus the O2 plus the H2 in there. Where in the world did they come from? How did this happen? Now, the next trick, guys, is we can start canceling. Because ultimately we want O's and H's, right? So we're going to cancel. So guess what? The O2's here cancel out. That makes it easy. And guess what? The H2's also cancel out. So now we're left with 2O plus 2H gets us 2OH. Okay, we're on the path. Now in this case here, we're going to add all those numbers up, okay? Now to save time, I'm not going to go and show you the math. You guys should know the math, but you're walking away with, for this, that delta H0 is equal to negative 853 kilojoules per mole. But is that our final answer? And Johnson already knows this, but it's not the final answer, because what we're interested in is for 1 mole of that stuff. So the ratio here is not working out. It's 2 to 2 to 2. That's cute. How do we get rid of the 2's? Well, remember, the important thing is to have 1 mole of this. That's our goal. Okay? Well, in this case here, this is going to be really easy because we can divide this by 2. So in order to make this work, ladies and gentlemen, we're going to have to divide by 2. Okay? So that we get it for 1 mole of OH, which we walk away, ladies and gentlemen, with negative 426.5 kilojoules per mole. And that, ladies and gentlemen, is our final answer. So if we're producing 1 mole of OH gas, it's going to be explosive. It's going to be hot. Man, I'm feeling it. Are you feeling the heat? Feel the heat. Ready or not, it's hot, hot, hot. Exothermic. And with that, I'm Trev Lucas Spa Woo, and let's face it, you're not. Catch you on the flip side.